I've got an inheritance challenge for you! Again, everything you need is in the playground for this part of the course. Pause the video and do your best to work through the exercises. Then come back to see how I did things. Have fun! First, create a class named Animal that has a function named Speak that does nothing. That's pretty straightforward. That class doesn't need an initializer because it doesn't have any stored properties, just the one method. Next part, create two animal subclasses. Number one, a wild animal that has an is poisonous property that is a bool. This one does need an initializer to set that is poisonous property. Subclass number 2 should be a pet class that has a stored property named name that's a string. That one also needs an initializer to set its property. Pet also needs a play method that prints out a message. You could have done whatever you wanted with the parameters for that, but I just kept mine simple. And the final thing for pet, it should override speak and print out a message. I went ahead and used the name property in that message. All right, the last part of challenge 1. This was more open-ended. Create one subclass of your choice of wild animal or pet. It should do at least one of the following: override speak, override play, add a new computed property, or add a new method. I'll make a cat class that says what all cats say. iCan has cheeseburger. Note the override keyword in front of that method. On to challenge 2, casting. Create at least one instance of each class from the first challenge. I made 2 wild animals, baby Aragog and baby Smaug, so one could be poisonous and one not. Next, create an array that contains all of the instances. Swift is helping me out there because it can figure out what the common parent class is for all those instances. Now for the potentially longest part. Write a function that takes an animal and does something different depending on what subclass it is. This part is particularly vague, so you could have made it as complicated or simple as you liked. I'll write a function that prints out the pitch you give to your family when you bring home some kind of animal and want to keep it. The challenge suggested conditional downcasting, so I'll try that first with if-let, checking for wild animals. If it is a wild animal, I'll print out something different depending on if it's poisonous or not. I just use a ternary operator for that, but you could have used if or even a switch statement. Note that I also used return at the end to make sure the function stops running after the message is printed. Next, I'll check for pets. And inside there, since I have a cat class that derives from pet, I'll switch things up and use a switch statement to pick the right printed message. When you use a switch statement and you want to see if you can downcast, you leave off the question mark. And then, because pet only has the one subclass, I'll use a default case to catch regular old pets. I could leave it at that, but I'll add one more print statement if none of those casts succeed, and at that point, I could assume it's of type animal. The very last bit of this challenge was to call the function with each of your instances. I'll do that with for each. And there's all of the possible messages in the console.